The de Havilland Comet 1 pioneered jet travel, but its square windows and punched rivets proved to be fatal. In 1954, two of these innovative airliners suffered catastrophic mid-air breakups over the Mediterranean. Crash investigators discovered that the sharp window corners acted as severe stress points, allowing tiny microcracks from punched rivets to expand under pressure and tear the aircraft fuselage apart. The McDonnell Douglas DC-10 had a design flaw in its outward opening cargo door. In 1974, Turkish Airlines Flight 981 suffered an explosive decompression over France when the cargo door blew off mid-flight. Because the locking pins were not fully engaged, high pressure forced the door open, causing the cabin floor to collapse, which severed all hydraulic lines and left the pilots with absolutely no control. The Boeing 737 MAX featured an automated software system called MCAS, designed to push the nose down to prevent aerodynamic stalls. However, the system relied dangerously on just a single angle of attack sensor. In 2018 and 2019, two fatal crashes involving Lion Air and Ethiopian Airlines revealed that a single sensor failure could trigger MCAS to repeatedly force the nose down, overwhelming the desperate pilots. The Boeing 737 Classic harbored a hidden danger within its rudder control system's dual servo valve. Under sudden thermal shock, the valve could jam or completely reverse its command. This catastrophic flaw went undetected for years, causing US Air Flight 427 and United Flight 585 to roll violently into fatal, unrecoverable dives before investigators finally pinpointed the hardware malfunction and ordered a redesign. The Lockheed L-188 Electra suffered from whirl flutter, a violent vibration triggered by weak engine mounts. If a mount was damaged by turbulence or a hard landing, the spinning propeller wobbled. This oscillation matched the wing's natural resonant frequency. In 1959 and 1960, two catastrophic mid-air breakups occurred, when this intensifying shaking generated enough force to physically rip the wings off the plane. The McDonnell Douglas MD-80 utilized a single-threaded jack screw to control its tail's horizontal stabilizer, lacking any redundant backup. In 2000, Alaska Airlines Flight 261 plunged into the Pacific Ocean because inadequate maintenance grease had worn the threads away. Under extreme aerodynamic load, the jack screw stripped entirely, rendering the stabilizer useless and sending the aircraft into an unrecoverable dive. The ATR-72 twin turboprop possessed de-icing boots that failed to cover enough of the wing's upper surface. In 1994, American Eagle Flight 4184 was holding in freezing rain when an ice ridge formed just behind the active rubber boots. This buildup severely disrupted airflow, causing an uncommanded roll that pilots could not correct. The aircraft crashed in Indiana, forcing a critical redesign of its de-icing systems. The Concorde suffered from vulnerable, unshielded fuel tanks inside its delta wings. In 2000, Air France Flight 4590 struck runway debris during takeoff, blowing out a tire. A heavy chunk of rubber slammed into the wing's underside. Instead of puncturing the metal, it sent a massive hydrodynamic shockwave through the fuel inside, bursting the tank from within and sparking an uncontainable fire that downed the jet. The Super Puma helicopter featured an epicyclic main gearbox susceptible to subsurface fatigue. Over time, contact stress on the gear teeth caused microcracks that propagated deep inside the metal without shedding debris. Because of this, onboard magnetic chip detectors were left blind to the danger. In 2016, a fatal crash occurred off Norway when the entire main rotor severed from the flying helicopter without warning. The Boeing 747 Classic had weak aluminum latch cams on its outward opening cargo door. In 1989, United Airlines Flight 811 experienced an explosive decompression over the Pacific when the locks failed. The door was ripped away, taking a massive section of the cabin wall and several passengers with it. Investigators determined that electrical shorts could trigger the lock motors, easily overriding the worn latch cams. The Lockheed L-1011 TriStar possessed an autopilot that silently disengaged altitude hold if the yoke was bumped, without triggering a master caution warning. In 1972, Eastern Airlines Flight 401 crashed into the Florida Everglades because the crew was distracted by a burned-out landing gear bulb. Unknowingly, they had nudged the controls, causing the jet to fly into the ground while they thought autopilot was on. The Martin 202 adopted a newly developed zinc-aluminum alloy for its wing spars to minimize weight, which turned out to be highly vulnerable to stress corrosion. In 1948, Northwest Airlines Flight 421 lost a wing in a thunderstorm. This tragedy revealed that the alloy was prone to rapid, hidden fatigue cracking. The discovery compromised the entire operational fleet and forced expensive, major structural overhauls. The Boeing 787 Dreamliner integrated high-energy lithium-ion batteries into its electrical grid, but lacked adequate safety isolation between cells. In 2013, a series of thermal runaways caused intense battery fires and corrosive smoke, prompting a global grounding of the fleet. The aircraft were only allowed to fly again after Boeing designed robust, heavy-duty steel containment boxes to encase the battery units. The McDonnell Douglas DC-9 utilized Class D cargo holds, designed under the flawed assumption that any fire would suffocate itself from a lack of oxygen. In 1996, ValueJet Flight 592 crashed because improperly secured oxygen generators caught fire. Generating their own oxygen, the flames raged out of control in the unmonitored hold. This disaster forced the FAA to mandate smoke detectors in all cargo compartments. The Embraer 120 Brasilia relied on a titanium fine-pitch stop mechanism that was highly susceptible to spline wear. In 1991, Continental Express Flight 2574 crashed after a worn propeller system slipped past its safe limit in flight. The blades flattened out, acting as a massive aerodynamic brake. This generated extreme asymmetric drag, throwing the turboprop into an instant, violent dive that tore the wing off. The Airbus A320 pioneered automated flight envelopes, but its alpha-floor mode created pilot confusion. In 1988, Air France Flight 296 crashed into trees during a low-altitude airshow demonstration. The crew tried to pull up, but the computers, misinterpreting the low speed and altitude data, delayed commanding full thrust. This famous crash exposed early integration flaws between human input and automated systems. The Mitsubishi Mu-2 omitted traditional ailerons to allow for full-span wing flaps, relying solely on spoilers for roll control. In icy conditions, this setup proved dangerous. If ice built up, the airflow over the wing detached. Deploying a spoiler to turn would stall the wing instead of rolling it. This led to many low-altitude spin accidents, forcing specific pilot training and restrictions during icing encounters. The Piper PA-28 family utilized a manufacturing process where wing spars were cold bent to create the dihedral wing angle. This locked severe residual tensile stress inside the metal around the bolt holes. Over thousands of hours, this trapped stress caused hidden fatigue cracks to develop. In 2018, a Piper wing sheared off in mid-air during a flight, proving these micro cracks were invisible to annual inspections. The Bristol freighter featured a bulky, boxy fuselage that channeled highly turbulent air directly into its tail. The internal structural bracing of the tailplanes lacked stiffness against twisting forces. At specific flight speeds, the tail would enter violent, uncontrolled twisting movements known as aeroelastic flutter. This intense stress caused multiple tailplanes to snap off mid-flight, bringing down the aircraft. The Tupolev Tu-144 utilized retractable mustache canards near the nose to maintain low-speed stability. But this design placed severe stress on its underlying structural frame. During a steep pull-up maneuver at the 1973 Paris Air Show, the massive aerodynamic forces exerted on the canards overloaded the fuselage bulkhead. The nose buckled, structural failure ripped through the wing, and the jet disintegrated on live TV.